In this last video for this particular module, I wanted to talk about how to get information from the graph of a function. So we've already talked about basics of mathematical functions, graphing, but I wanted to kind of review how do we actually read a graph and find that information, especially using the function notation. So let's look at an example from the packet. It says, let's assume the graph to the left is a function of t of x, the temperature starting at noon for one particular day. And this does not appear to be the temperature in San Diego, especially right now where it is 1,000 degrees. So we don't know where this is, but let's just try to read it and find some of the information to answer the questions. So first of all, it says find t of 0. So since t of x is based on the temperature, where x is a time starting at noon, what we could assume is that on the x-axis, 0 is going to correspond to noon. So 1 would be 1 p.m., 2 would be 2 p.m., and so on. But sometimes the values on the x-axis might not necessarily be their numeric components. Sometimes they might correspond to something else, and you know that would need to be information that you'd be told in the particular example. And notice that t of 0, when you plug in 0, that's always the y-intercept, because it would give you, well, what is the y value when x is 0? Or, you know, this is the location of 0, so I'd have 0 comma, it appears to be 15. And, you know, if you don't have a formula and you just have a graph, you just do your best to determine the value of the point at the particular location. So I would say t of 0 is 15. And again, what that means is, well, the temperature at noon is 15 degrees Fahrenheit. And you could write it using the units or just using the value of the number. It depends on, is it asking you a question or is it asking you more of a mathematical statement? Next question asks, what is the temperature at 5 p.m.? So, you know, in the same way I could say, well, the question is, am I looking at the x-axis or the y-axis? But the temperature is on the x-axis, time is on the x-axis, and the temperature is on the y-axis. So it's asking me, well, what is the y value when x is 5? Or another way you could write this is t of 5, right? Because that's exactly what the meaning of this function is. What's the temperature at 5 o'clock? And t of 5, again, I could go to 5 o'clock and look, well, what is it? It appears to be 20 degrees at 5. And again, I could write it using a mathematical statement, or I could answer the temperature appears to be 20 degrees Fahrenheit, just using the function notation to practice. Next it asks, what's the hottest time of the day? And this would be something where if we didn't have a graph or a function, how the heck would we know? But it appears to be at this point right here, the maximum, or at least the relative max for that, for this particular time frame. And it asks the hottest time of the day, not the hottest temperature. So in this case, we'd want to know, well, what is the domain value? Looks like 2 p.m. would be the hottest time of the day. I could also answer, well, what is the temperature at that point? But it doesn't ask that, so that's probably not correct. You could also answer it as an ordered pair, 2 comma, it looks to be about 35 or 34 degrees. And oftentimes we write a maximum as a coordinate as an ordered pair. And you know, like when I write something like this, t of 5 is 20, we could also write it as the point itself. Like, what is this point? 5 comma 20. These mean the same thing. These are synonymous statements. And so sometimes, you know, we might see it presented one way as a point or as a function or something. But anyways, there's a lot of ways we could express this correspondence within this function. And the last question here asks us, find the values of x for which t of x is equal to 25. So this question is a little bit different. It's sort of like asking, what is the input that produces an output of 25? So it's sort of like, what elements of the domain correspond to the range being 25? And notice it's plural because you can have more than one answer when it comes to input. And the way that I'd suggest looking at this is, since I'm looking for when the temperature is 25, I could kind of view it as a horizontal line through my function to see, well, when is the temperature this particular value? And it appears as though when x is equal to 1 and when x is equal to 4, the temperature is equal to 25 in both cases. So I'd have the point 1 comma 25 and 4 comma 25, and at both of those times the temperature is 25 degrees. So, and remember, this is okay with a function because you can have duplication in the range, just not the domain. And last but not least, you can, like in the last video, we can, or in a couple videos ago, we can use a graph to find the domain and range. And the way I'd usually recommend looking at it is by basically scanning where is the information. So as I'm looking at a particular curve, like in this case, our curve, goes up and comes down because that's what the temperature does, right? It gets hotter in the middle of the day and then cools off. But basically the domain is the set of inputs. What are the valid numbers for, basically, what are the valid times a day? Well, in the case of temperature, it could be any time of day. But if you're dealing with a very specific graph, you would usually want to write the domain based on what you're presented with. So I'd say the domain of this graph is 0 to 6, or I guess 0 to 7, because we have information going all the way to 7. And I'll go ahead and use brackets on my interval because it appears as the temperature, it's included to be that full value. Like the endpoints of the graph are usually implied to be closed circles and part of the graph. And basically all this is saying is I know for this function, I know the output from 0 to 7 p.m. Now I don't necessarily know the temperature at 9 p.m. or 7 a.m. and that's why it's not part of the domain. Though technically the temperature is defined every day, all day, every day. So in the theoretical sense, this function has a domain of an infinite domain, right? Continuing to infinity. We just don't know it because this is all we have. And same thing for the range. The range would be specifically, what is the range of the data I have? And be careful not to just say 0 to 50 because it's always where the function is, what values it actually takes on. Like what's the actual temperature range for the day, right? That's like the real term for what we'd say. It's like, well, what's the smallest value of the function and what's the largest value? What's the min and the max? Which appear to be the smallest value it takes on is 15 and the largest is 25. And it doesn't take on values like 10 degrees or 0 degrees, and it doesn't take on 60 degrees either. So it's specifically just within this range from 15 to 35. And again, its range is always done from bottom to top. And it's, this graph here helps the visualization process for scanning a graph and trying to determine the domain and range from that. You want to know from left to right, where is it for domain, and from bottom to top, where is it to find the range. And again, I would use brackets here because it appears to take on all temperatures in between 15 and 35 and include the endpoints. And again, you might be splitting hairs and say, well, does it really get to 35? And again, we don't know exactly because this graph is just, it's not, we don't have the individual data points, but we can just use use your best approximation whenever you're faced with graphs such as this. And this will end the lecture for right now. Now, in the next couple of days, I will be posting the last few sections of the lecture video, which are also due before we have class next week, but this is good for right now. And again, as I suggested at the very beginning, I suggest working on the homework as you go. You should be set for working on those first couple homework assignments in my math lab. Anyways, as usual, if I missed anything or if you have any questions at all, shoot me an email, come to my office hours, make an appointment, and I will be happy to help you however you think is best. Anyways,